In this tutorial, I want to talk more about shapes and meshes in Gideros and try to distinguish between them because they're somewhat related. Let me start by creating a new project. I'm going to create the project in Gideros examples and I'll call it shape. I've asked Gideros to create a new directory for my project, so it will create a directory called shape and the project file will be called shape.gproj. Here's my empty project, and here it is in my file system. What I want to do first of all is grab some graphics from another project I made earlier. Let's grab these graphics, copy and paste them into examples. Okay, so all my graphics are there that I'm going to need. And I now add existing files. I'm going to add all of these graphics to my Gideros project. So there they all are. And I need to add a source code file, which I will call main.lua. Okay. Let's start. The first thing I'm going to do is create a shape. So I do shape equals shape.new with no arguments. So to begin drawing the shape, I do shape move to 0, 0. So this defines my first corner of my shape, which will be made out of line segments and will be a polygon, which I will fill. Shape line to 220, 0. Shape line to 220, 240. And finally line to 0, 200. And now I'm going to close the shape using this convenience function, close path, which simply links me back to the 0, 0 coordinate. So now I've created a quadrilateral, which actually isn't a rectangle, but of course I could do a rectangle if I wanted to. Okay, I've forgotten to have a begin path. Every shape should start with a begin path and work its way through to an end path with various line segments in between. Let's start Gideros player. Press play. It hasn't drawn anything yet, and the reason is I've, made two mistakes. Firstly, I need to define a fill style or a line style. If I don't define either one, then the shape will just be invisible. Let's start with a fill style, and I'm going to use a solid fill, solid color. I don't need to say which color, so let's use red. So this means full red, 0 green, and full blue. Red, green, blue, in that order. Let's also not forget to add the shape to the stage, without which it will not appear. Let's see, there we have our shape. Let's set the shape's position. Slightly offset from the corner, 10, 10 pixels. other thing I can do with a shape is to add a line style. So I can surround the shape with a border. Let's make it 4 pixels thick and blue. So now I surrounded my shape with a border, and I could have any number of line segments to create an arbitrary polygon which is filled. Of course I can change the color. Let's make it both red and green, which gives surprisingly yellow in computer graphics. To make things a bit clearer, I want to change the background color. Application, set background color. Let's choose a color which is halfway between black and white. So I'm going to choose 80 for each of the channels, red, green and blue, giving me a grey color. So that's a good use of shapes, but it's not the only use. As well as filling a shape with a solid color, it's possible to fill it with a texture. That should be capital letters. Let's just minimize this for a minute. So when I specify a texture, I need to actually create my texture. I can create it right now using texture.new. And I'm going to use the field texture. Field.ping. Let's zoom out of there for a minute. You can see field.ping is not here for some reason. Let me add it. Okay. Let me go find field.ping, which I've misplaced. Add it. Alright. There it is, field.ping. You can see, actually, this is almost a useful mistake because you can see that I can actually have my ping files in different directories. They don't all need to be in the same directory. Okay. So that's all I need to do to fill my shape with a texture. Of course I could have created my texture up here as well. I could say texture equals texture.new. So I create a texture and then just use it. Or I can create it within the function call itself. Let's do it that way. So I've got my texture and I fill my shape with my texture. Let's see if that works. Good. So you see I have filled my shape with a texture. Because my texture is bigger than the shape, it starts at the top left corner of the texture and fills as much of the shape as it can. Let's consider filling my shape with a small texture. So in this case, the texture is only 80 by 80 pixels, so it won't fill my entire shape. Let me revert to the previous style and just put the texture in within the function call. This makes it quicker for me to change it later. Let's call it ball.ping. Okay. And you can see it looks a bit odd because there's these kind of dirty stripes going across. And one solution to that is just to have an extra pixel, which is the color you want, and then it will repeat that across horizontally and vertically. This is kind of a limitation of OpenGL. But typically you would be cutting out your polygon from a texture that's bigger than the polygon, so you use only some of it, so the issue doesn't apply. The main case in which you would want the texture to be smaller than the polygon is if you want to repeat the texture, and that's what we'll get onto next. But let me just show you ball 2. In the case of ball 2, I've actually wrapped it round with a black border within the actual texture, within the ping file. So if I use ball 2 instead, then there's no problem there, and you can see the blackness is repeated in the remainder, the unfilled portion of the polygon. But normally what you want to do is you want to repeat the texture so it fills the entire polygon. And to do that, when I create the texture, I'm going to add another parameter, which is a Lua table. And this table should contain a single element called wrap. And if I set that to the symbolic constant texture.repeat, then it should repeat the texture across the entire polygon. And you can see that works very well. And the reason it works well is because I've chosen my ball to be a power of 2 texture. So whenever you're repeating a texture across a polygon, your repeat unit should be a power of 2. In this case, it's 128 by 128. But if I were to revert to the ball, which is not a power of 2, as you can see, it's 80 by 80, then I will get some sort of artifacts, and you can see I'm again getting these dirty stripes, but also the ball is not repeating where it should, right? The ball is only this big, and yet there's a big hole between it, and that's because basically in OpenGL, and probably in DirectX as well, and Gideros supports both, you do need powers of 2 when you're repeating a texture. So the best thing is to choose a power of 2. I have another ready-made one called chessboard, and this one is only 16 by 16, but it's a power of 2. Typically a repeating unit might be very small. So if I choose chessboard as my texture to repeat, then I get a nice chessboard, and I could use a brick wall or something of that sort as well. And I want to create another shape. Let's turn this off for a minute. Let's minimize this. I'm going to call my new shape shape 2, and it will be a shape.new. Again, I'm going to choose now this time I want to have a single path between begin path and end path, of course, as usual. But what I'm intending to do now is to get this ball and draw it on the screen. Of course I could do that easily with a bitmap, but what I want to do is draw only half of the ball, namely the top half and the bottom half of the ball, and I want them to be in separate shapes. So this will show us how we can cut up a texture and manipulate the 2 bits of it independently. So let's make this shape fairly small. Call it shape 2. Move to 0, 0. Shape 2, line 2. Now the ball is 80 pixels wide and 80 pixels high. So I'm going to cut up half of it, so my rectangle is going to be 80 by 40. And let's close my path as well. Right, let's not forget to position the shape somewhere. I'm going to put it at 10 by 300, and I'm going to remember to add it to the stage, otherwise it won't appear on the screen. Okay, again I'm not going to see anything just yet. And the reason is I haven't set any fill style or line style. So, shape, set, fill style. fill style. And I'm going to texture this shape, so I'm going to use shape.texture. And the texture I'll use will be the ball. I'll create a ball texture to add in. And the true argument means to use filtering, which is basically anti-aliasing to make the ball look better. So if I do that, I should see the ball. Nope, instead I have an error. So we're saying, let's have a look at this error here. Line 19, oops. Bad argument number 1. Yes, so what's happened there is I should use this symbolic constant shape.texture, which is all in capitals. Let's see if something appears on the screen. So now we have half of the ball as I wanted. So you can see I can divide a shape into 2 parts and just draw one part of it. I now want to draw the bottom half of the ball as another shape. So let's copy all of this. I'm going to call this one shape 3. And this shape is exactly the same dimensions, so it's 80 by 40 and it's a rectangle. I still want to use the ball. Now let's position it differently. Let's put it at 10 by 340, so it's directly underneath. And we add it to the stage. So I've got the top half of the ball again, but what I wanted was the bottom half of the ball. So to achieve that, there's a third argument I can add to set fill style, which is the matrix, a matrix. Now a matrix is a 3-dimensional, well, it's a 3 by 3 grid of numbers which dictate how this ball will be shifted when I look for the texture. I create a matrix using matrix.new, and in this case it's very simple. All I need to do is leave these first 4 numbers as 1, 0, 0, 1, and then the last numbers are just going to be the displacement I want in pixels. So I want to displace my texture by 40 pixels down. So what this has done is it's created a matrix. Let me go look at the documentation to understand what a matrix is better. If I go to the reference manual and look at the matrix, which is one of the classes, you can see here it shows you that there's a matrix. This bottom row is always 0, 0, 1. The top block, called M11, M12, M21, M22, really dictates scaling and rotations. If you want to do no scaling and no rotation, then M11 should be 1 and M22 should be 1, and the other two, M21 and M12, would be 0. And in our case, all we need to set is the translation bits. So I want to translate it by 0 in TX and translate it by minus 40 pixels in TY. When I do matrix.new, I think the documentation gives an example. So you can see you can create a skew matrix and some other examples. Let me just check what matrix.new does. You can see it takes the top left block first, these M values. So the default values is what we want to keep. So 1, 0, 0, 1. The last two, the TX should be 0 and TY should be minus 40. So that creates the matrix I want, and all that's going to do is it's going to cut out the bottom half of the ball, which is what I want to achieve. So if I run that, you can see it looks like the ball is a single object, and there's no seam, which is good. But if I separate the two out, and I put the shape 3 a bit further down, you can see they are separate objects. to have some fun with this, I'm going to create a callback function which moves the top half of the ball. It's going to be called update. I'm going to set a global variable called t and initialize it to 0. Every 60th of a second, this update function will be called. And I'm going to move shape 2. I'm going to set its y-coordinate to be its initial y-coordinate, which is 300, because if you look at it, you'll see shape 2 is now positioned at y equals 300. I'm going to subtract off math.sine of t and to the power of 4. So sine goes from 0 to 1. When you raise it to the power of, well, the sine function goes from -1 to 1. When you raise it to the power of 4, you have a number that goes between 0 and 1. I need to multiply this by an amplitude. I'll choose 50 pixels. So now the object is going to bounce up and down and return to its starting point. Okay. To make this work, I need to register this update function with the system. I'll add it to the stage, so I'll add an event listener, and the event will be an enter frame event. Update, that's all I need to do. So hopefully the top half of the ball should now start moving. Yep. Let's just move the bottom half back to where it should be so that they will touch. And to make this a bit more Python-esque, I'm now going to add another bitmap, someone inside the ball, so I'll put him behind the ball. So let's say bitmap equals bitmap.new. The bitmap is based on a texture. Let's add this ping file, and I will use anti-aliasing. What does that do? Nothing yet. Well, let's add the bitmap to the stage. Okay, well, I want to put this handsome fellow inside the ball. I'm going to scale him down because he's far too big for his own boots. I'll scale him to a factor of 15% in the x direction and 12% because his head is too big, it's too tall. And I'm going to put him in position in pixels, of course, 30 by 305. Well, he's positioned right, but I want him to be in the ball, or look like he's in the ball, like an egg that's hatching. So I'm going to do add child at, and I'm going to put him in position 1, which means he's behind everything else on the stage. Everything else will be drawn on top of him. Quite Python-esque. So you can see how you can cut up shapes and move them around independently, and you could use this sort of technique to create a jigsaw puzzle or something like that from any image, which is a texture, and then it's split up into parts. Now I want to start using meshes. A mesh is a different object but somewhat related to shapes. We start programming a mesh by using mesh.new. And what a mesh is, it's just a lump of triangles, a group of triangles put together. So I need to set the vertices of these triangles, and I can also set their colors and texture coordinates if I have a texture. So let's start off simple and create a single triangle. Mesh set vertex. And the index number of my vertex is 1, my very first vertex, and its coordinates will be 0, 0. Let's set vertex again. My coordinate number 2, my vertex number 2, will be at coordinate 150 by 0. My third coordinate will be 150 by 150. So that's enough to create a triangle. Now I also need to do something called setting index array. So what I'm going to say is my first element of my index array will be vertex number 1, which is this vertex. So what I'm doing is I'm sort of telling it how to draw the triangle. I'm saying take index number 1, then take index number 2, then take index number 3, which is kind of a trivial thing to say, but later on we'll see that we can possibly reuse some vertices to make multiple triangles out of a small number of vertices when they're all stuck together. So I must set that. That completes my mesh, and it should create a single triangle, which is going to be 150 pixels wide. It's going to be a right angle triangle. As usual, I must add my object to the stage. And let's position it so it doesn't overlap the rest of the scene. Right. Let's zoom out of that and let's see if this will appear. So there you go. I've created a triangle. And of course I could have done that with a shape. But the beauty of meshes is I can create a huge number of triangles and blast them all onto the screen very rapidly. So it's a much more low-level thing than shape. Okay, what I didn't do was color my triangle, and I just left it, I didn't specify the colors, so it defaulted to white. Let's set the colors of the vertices. So it's a different concept from shapes. With shapes you set the entire fill color of the whole shape, but with meshes you set a color for each vertex. So we'll see what that means in a minute, but for now let me just make them all red. So I'm going to set all 3 colors to be red. So full red, no green, no blue for all 3 sides. And now I've got a red triangle. But I can set the color on a per vertex basis. So if I set one of the colors to be full green, one of the vertices, then you can see at this second corner it's completely green and the other 2 corners is completely red. So I can use this technique to do a gradient approach, gradient fill approach. So it's quite nice to do that. Of course I could set the third color to be blue, a completely different color, so now I have 3 different colors and I get this nice gradient effect, which is not possible with shapes. Okay, let's try and draw a rectangle. The thing about meshes, I can't draw arbitrary polygons. I must draw only triangles. So I'm going to need to create a third, or rather a fourth vertex at position 0, 150. I'm going to need to set its color to something as well. Let's just keep the same color. If I want, what I'm trying to do now is draw a rectangle. Now the index is where it gets interesting. In the first case I've used all 3 indices and there's only 3. So this is index 1, this is index 2, this is index 3. And I'm telling it how to make a triangle out of those. But now I'm going to say make another triangle. So for number 4, the index number 4, I'm going to reuse vertex 1. And then for number 5 and 6 I'm going to use vertex 3 and vertex 4. Which is, vertex 4 is the new one I've added. So this is 1, 2, 3 and 4. So if I do 1, 3 and 4, I'm defining this triangle down here. So that's how I reuse vertices. And you notice the number of elements in this index array is always 3 times the number of triangles. However, the number of vertices might be less than this because I'm able to reuse vertices. So there you go, I've created a rectangle out of 2 triangles. And I've used the gradient fill effect. Let's try doing something a bit more realistic, perhaps, that you might want to do. So red and green so on one side, on the right hand side, on the left hand side is going to be red, on the right hand side it's going to be green. So there's a gradient fill that looks quite nice. Of course, there's nothing to stop me from rotating my sprite if I wanted to. And of course the whole thing rotates like that. Nothing wrong with that. But what you could also do is create a kind of shadow effect. So I'm going to make it red on one side, but a dark red on the other side. So this is half saturated red on the other side. And now you can see I have a kind of shadow effect. Probably it's a bit too subtle here. Let's do that again. So now you can see how I can create this gradient effect, which looks like there's a shadow. So I can do some good things like that with mesh. The other thing I can do with mesh is I can, instead of filling each triangle with a solid color, I can fill each triangle with a texture. So let me, what I need to do at first is to set a texture for this mesh. And I'm going to use the field texture. Now what I need to do next is I need to set texture coordinates for each of my vertices. So set texture coordinate. For number 1, I'm going to use 0, 0. So what I'm going to do is I'm going to pull out bits out of this field. So 0, 0 is the top left. And I'm going to have 4 of these, for each one for each vertex. And it is in pixels again, so it's 150 by 0, 150 by 150. Well, I'm going to choose 150. The whole texture is bigger than that, but I'm not going to use the whole texture. I'm going to use 150 pixels out of it. There we go. If I run that, okay, I got an error on line 61. Okay, so I just forgot to close this bracket here. So you see I managed to cut out some of the football field, but because I set colors here, I've actually set the whole field to red. What I'm doing is I'm filtering the field only to allow the red bits through, and the only bits that have any red in them at all are these white lines. Typically if you're using a texture, you don't need to set the colors as well. So if I just cancel that out, I can use a comment. This is a multi-line comment, so I comment that out, and now I should see the football pitch. So I've defined a portion of the football pitch. But it is useful to be able to set these colors sometimes. If you don't set them, it defaults to white, which means the entire thing shines through, so you see absolutely everything, which is what we're doing now. So I'm setting all the vertex colors to white, so I just see the original texture without changing it. But you might want to filter it, so let's you might remove the red bit, or rather the green bit in one side of it. Actually, let me remove it from here. So now you can see there's a kind of yellow shading going on. And you can have other effects like that. Or if you move the green from one of the corners, then you have another shading effect. So you can create various gradient effects that way. And of course I could revert to just having a single triangle if I wanted. Let's just have a single triangle which I've textured. Then I can comment this out. So that would just be one triangle. Okay, well that concludes what I want to say, and you can see how both shapes and mesh classes can be used both with solid colors, gradient fills, or cutting out various pieces of texture, so that you can do things like a jigsaw puzzle or something like that, so by cutting up shapes and cutting up images. The thing you really use meshes for, however, is to create huge numbers of triangles. So you could use it in creating a particle system like the exhaust from a rocket ship or something like that. That's really the main use for meshes. So I've only had 2 triangles so far, but actually for a real mesh you might have 10,000 triangles. And because it's a single object, Gideros draws it all at once with a single draw call to OpenGL. So it's much more efficient to have a mesh with 10,000 vertices than to have 10,000 meshes with just a few vertices each, or 10,000 shapes. So that's really the main power of meshes, is that it's extremely fast.